What's up guys, welcome back to another Google SketchUp tutorial video. Today we're going to draw a pressure vessel. We're going to be drawing the main body, doing the dish ends, attaching manways and nozzles. At the end of the video we'll have a look at how we can put on some C-scan corrosion mapping data on the vessel body. Okay, so the first thing we're going to do is have a look at a 2D general layout of a vessel. This particular sketch doesn't give us too much information, but the information that we'll be looking for will be the overall length of the vessel, the diameter of the vessel, all the relevant thicknesses for the headers and the shell, and the nozzle design data giving us all the nozzle diameters and nozzle thicknesses. So let's head over to Google SketchUp and see if we can recreate this as a 3D model. First thing you want to do is get the radius of the vessel by taking the diameter, dividing by 2, so you can draw the circle, and then you will rotate it and extrude it because this is a horizontal vessel. So drawing the dish ends, we weren't particularly given the exact dimensions, but it's the same technique. If you are given the dimensions, this is what you can do. You move from the outside into the center. You then come along the axis, giving yourself some room to draw with, and go up and giving yourself a bit of a flat spot after the weld, and then using the arc tool, so this will be a new tool that we haven't used just yet, giving yourself a decent arc and then getting rid of the sharp edge over there. So at this point you've just got one slice of the dish or the header, and you can use the follow me extrusion tool, which is another tool we haven't used just yet. So clicking on the surface once, dragging it up, and it will give you a nice dish end. So we've got two lines there. This line is very easy to get rid of. All you do is highlight it, right click and say soften. As soon as you go past a certain degrees, it softens all the lines, so you want to put it about 20 degrees. It'll differ depending on how much of an arc you have. So before we just copy and paste the dish end onto the other side, we might want to put a weld on. It doesn't particularly have to be a specific dimension. This is only for added detail. So again, using the arc tool, you might not want to make it a complete half circle, but again, all you need to do then is get your little arc for your weld, use the follow me function tool again, and you might have to zoom out and go around the vessel. Sometimes it doesn't just snap and know exactly what you want to do, but you just got to follow it around, and once you get to the end you can click. So again, we got some lines that we don't particularly want there, so we can highlight them, right click, soften, and again if we just increase it a little bit, it takes away all the unwanted lines. Okay, so now we're ready to put the dish end on the other side. So all you really need to do now is highlight the lot, Control C for copy, move across, Control V, and we'll just swing it around 180 degrees. Get yourself in a nice view where you can see everything. And there you go. Now see, we have two dish ends. So getting the two circumferential welds into the shell, basically I've drawn a line from the one side to the other, so taking the vessel length dividing by 3, which will give me the spacing I need. I then highlighted the circumferential weld, Control C and then Control V, and again Control V, and I've got the two circumferential welds, and I can soften these two lines again. Okay, so drawing the nozzles, I'm going to show you how to do one of these, and every other one will be exactly the same method. So what you need to do is I start by putting in a reference line to the point where I want the nozzle to be, go up on the axis that I want the nozzle to face, put the circle of the diameter, so using the radius to draw the circle, delete the reference line, get rid of the reference line that was placed on the vessel, extrude it down into the vessel, use the offset tool to offset the flange and extrude the flange face. And there you can see we've got a nice 6-inch nozzle with a flange on the top of the vessel. So at this point I have added all the nozzles on the vessel to the dimensions that were given to me in the nozzle design diagram. So you can see all the nozzles on the vessel. All I need to do now is move the manway slightly off center, so it's easiest to obviously draw from the center of the dome, and all I do then is highlight it, move it down just below the center, and there you can see it should look a bit more like the image. We're just going to quickly draw the pedestals for the vessel, so I'm just speeding this up, but it's using all the basic same tools again, using the arcs, drawing lines, extrusions, and we're just creating some pedestals for the vessel to stand on. This isn't particularly to scale. I'm just trying to speed the video up a bit so that it doesn't take too long. As you can see, I'm just setting in all the webbing. This particular part of the drawing doesn't really get much attention anyway, so it doesn't really matter. Giving it a bit of a base. And just putting the webbing in and placing them onto the vessel using the reference lines like we did before. Okay, so we're ready to paint the vessel. What I normally do is highlight all, get a nice metal color, give it a few clicks. Sometimes it doesn't always get all the surfaces the first time around. You can then, if you want to make it look a little bit more fancy and stick out, is do all the welds slightly darker color. Okay, so the vessel's basically complete. I have noticed I made a mistake. I've drawn the 2-inch vent nozzle at the back end of the vessel instead of the front. It's not a problem. All I did was draw a reference line, grab the nozzle, dragged it across, and deleted the reference line after, and everything it is in the place where it should be. Okay, so the last thing we'll look at is how to put some C-scan corrosion mapping data onto the vessel shell. I will say that this does take quite a bit of time. If you were doing a particular vessel like this, I think when I did this job, it took me about 2 weeks to corrosion map the whole thing. And as I was doing it, as you go along, you can start putting them in at the end of every day. I didn't even end up using the full C-scan model. I generally just do a 2D layout and then use this more as a reference to weld numbers and nozzles. But it can be done, so I'll show you a quick example. What I've done here is normally your particular scan would be a 500 by 500 scan. So I've just drawn out some, say, C-scan 500 by 500 sections. Open up your paint tool. You can then create a new paint. You would then go and browse for your paint. Open up your C-scan data. This can be a PNG, a JPEG, doesn't really matter. Now, looking at the size of it, we want a 500 by 500 section. So you want to go and make it 500 by 500. Click OK. And when you paint, you're actually painting your C-scan corrosion map data snipped out of TomoView or OmniPC, whichever one you prefer to use. And it does look quite good. Obviously, for every square you're going to need a different paint overlay. So for the time it takes to do that, I've never completed a full-size vessel this big before. You can soften the lines between afterwards. Just like this. Again, you can see this is something that will take quite some time to do, and you would obviously need to justify it maybe for a presentation or, you know, one good image for a website or something. Obviously these are all the same. There's that repeat little spot, probably a surface related indication or something. So yeah, definitely can be done. If you got the time to do it, then definitely do it. Thanks everyone for taking the time to watch another one of my videos. Next time we'll be looking at how to draw a 3D isometric pipework, taking from a standard isometric and converting into a 3D model. Again, thanks again for all the likes and comments and sharing my videos. I hope it's inspired people to do some more drawings. And again, you can go and check out all my uploads onto opensourcendt.com, YouTube, and of course here on LinkedIn as well.